Okay, so let's consider this problem that is taken directly from your notes. I believe it's page 8. And it reads, suppose E of t represents the number of people employed by a certain company, where t is the number of years, should read t, it looks like an x, is the number of years after January 1st, 1981. Suppose, shown below is the graph of E prime of t. There's a prime right there. The derivative function. The large numbers in the graph represent the area bounded by the graphs and the x-axis. Okay, so if you look further down, then you'll see this graph. And we have to ask ourselves, well, what is 206? What is 49? What is 449? What is 802? Well, this represents this region right here. And so this must somehow be linked to the antiderivative or the integral, just as we've been doing thus far. So I said that if you're trying to find the antiderivative, we're going from 0 to 6 of E prime of t dt. Notice what happens. This region has to be that is trapped between E prime, the x-axis, x equals 0, and x equals 6. So here's the pinch, E prime and the x-axis, there you go. And then the other pinch is between 0 and 6. So that's what this is, but you have to be careful because this antiderivative is directional, as I said in my last video. This should equal negative 206, right? To indicate that the region is below the x-axis. Now we could do the same thing for the other ones as well. This next one is the integral from 6 to 10 of E prime of t dt. Okay, so this region is trapped between E prime and the x-axis. There's the pinch, see? I'm pinching those two together, but it has to start at 6 and end at 10. So that's how I knew that this is the region that I'm talking about. This equals positive 49, right? So I could do the same thing for this one. So this is the integral from 10 to 18, E prime of t dt, which equals negative 449. And then over here, this last one, this is going to be the antiderivative or the integral from 18 to 24 of E prime of t dt. All right, so one other thing that we need to take into consideration is what are we left with when we take the antiderivative of E prime of t? Okay, so in each case, and I'm going to put that at the top so that you can see what I'm talking about. In each case, we're taking the antiderivative of E prime of t dt, and notice your antiderivative works on your derivative. These two counterbalance each other, and you should just get E of t, right? So let me be careful because I have to read what this says. Please look directly at your sheet. Suppose E of t represents the number of people employed. So this is the number of people employed. Whereas E prime, what your label is saying how fast the people are growing or falling, right? So notice what this one indicates, this very first one, is that you lost 206 people, right? Because as I said, I'm going to zoom out so that you can see what I'm talking about. Right? If E is the number of people employed and you're finding these antiderivatives, then this should be 206 people, right? Which means that your overall population dropped by 206. This one means that you hired 49 more people, or 49 more people just came back to work. Here, 449 people left work or were fired, and here 802 people left, came back to work, okay, or were hired, right? So we're talking gains and losses in the number of people, all right? And this should make sense in terms of your graph of E of t. Okay, so let me zoom in on the graph label on this one because you do have to be paying incredibly close attention to the label. This is E prime. Okay, I'm going to flip to a printout of this exact same graph, and I'll show it to you. Hold on one second, please. Let me zoom out. So this is the exact same graph that you're looking at. Now the reason that I'm showing it to you here is because I want us to interpret this in terms of what we already have been doing. All right, so this is a derivative, e prime, which means that I want to worry about positive, 0, and negative, right? So let's see. E prime is in the negative region in here. Okay, so if I had to draw my lines, there would be one of them. This is going to be another one. This will be another one. Notice I'm going all the way back to that table that we had. So from here to here, E prime is less than 0, and this means E is decreasing, right? So let's go over here. And you'll notice in this region, E prime is above the x-axis. So E prime is positive, which means E is increasing. Okay. Now in this region over here, you notice E prime is below the x-axis, which means E is decreasing again. And then this last region that we have here, E prime is above the x-axis, so E is increasing. All right, let me put that last arrow in. Right, make sure that you're increasing and decreasing to your critical points, these points where you're crossing the x-axis, right? So don't fall short of that, otherwise your answers will be thrown off. All right, so I want to sketch out E. All right, I have to be careful because I learned that this is the number of people. It's not some random number now, right? It says that it decreased, E decreased, but specifically E decreased by 206. Okay, so let me assume that I start off with 2,000 employees. Now I could use any number that I want, okay, to make this point. Okay, so let's assume that you start off with 2,000 employees. According to this, you should have 206 fewer employees by the time you get to 206. I'm sorry, by the time you get to T equals 6, right? So you should go down by 206, right? So what you get right here is, I'm going to turn this to the side for a second. This is 2,000 minus 206. All right, let's get our calculators out. Give me a second. It is helpful to find these numbers because even though the numbers might not be a true reflection of what's going on, it will at least allow us to compare points to each other. Okay, so for this one I got 1794. Okay, so I was at 2,000, but right here when I drop 206, I'm at 1794. All right, let's go over here. So this says you have 49 employees that were hired back, or hired. Okay, so that means, notice E should be increasing, right? E should be increasing, but by 49. So that's not much more. It's actually less than the 206, so don't go up that much, right? So it should be going up by 49. So then I'm going to go to this number that I got here, and I'll add 49 to it. So this equals 1794 plus 49. Again, I'm only using these numbers so that I can make a comparison. So let's see, 1794 plus 49. I got 1843. Okay, and if I made an error, just shoot me an email. I am human, so I do err. Okay? So then notice here, it says that your original function, let me be careful because I don't want to throw you off. Let me label this function. This is E of t, right? We couldn't see it before, right? Okay, so according to this, E of t should be decreasing because E prime is below the x-axis. Decreased by how much? 449. It's right there, right? So you should drop pretty significantly here, right? So let me turn to the side. It's going to be this number plus minus 449, 1849 minus 449. I'm sorry, 1843. I'm not paying attention. Minus 449. And I got, this is 1394. Right there. All right, flip this back over. Notice it says when E prime is positive, E is increasing. Okay, if you don't remember these rules, you really need to go back because they do come back into play. This is one of our big word problems. And here's a dotted line that should be here because you do end up crossing the x-axis. So you increase by 802, which is a lot, right? Right, notice my arrow indicates that. So I'm going to take this 1394 and add to that 802. Okay, so this equals 2196. Okay, so there's a lot of stuff going on there. But what it does is it allows us to answer the questions fairly quickly. All right, I'll make this a second video.